Hi everyone, I'm Aaron Rump. In this video, we're going to go over a milling project setup for Vericut. And what we're going to do is we're going to go a little bit further from our last video, whereas we just created some models and some material and some tools. We're actually going to introduce bringing in fixturing. We're actually going to bring in a work holding device that we can use to hold our part, so that we get a little bit more real world idea of what we're looking at when we run our program. We'll go over building tools from a master tool list, so that way every project that we're making, we're not having to rebuild that tool list every stinking time. So we'll go over some more positioning skills and so on and so forth. So let's go ahead and get to it. So when I first open up Vericut, I'm going to come up to my welcome screen. If you ever need to get to the welcome screen after you open it, you just come up here to your help tab. We're going to go ahead and start with a new inch project. And then we're going to just start kind of like what we did in the last video. If you've already watched it, we're going to install our controls, our machine. We're going to go into our attachments. We're going to install a fixturing. We're also going to install our stock and our design, so our part model. We'll go ahead and do our coordinate systems. We'll add the G code. I'll show you how we're going to introduce a master tool list, how to grab tools from that master tool list. And then finally, we'll go over the NC program. So let's go ahead and go to control. I'm going to show you different ways to do this as we go along. After I click it, I can click on the browse folder and you'll see me go to my desktop. I'll include these links in the description below. If I'm going on my control, we'll go with the VF2. On this one, I'm going to right click on it. I could come down here and open that one, but if I want to go a little bit different route, again, I'll come up to my desktop. I'll go to the Vericut Files, machine, and I'll go ahead and grab a mini mill. And it's going to take a second to load because it's got a lot of attributes that are uploading. And so here's where it gets cool. We've got the easy stuff out of the way. I'm going to go to fixture, but before I do my stock or my model like I did in the last video, I'm going to right click, I'm going to go to append, and I'm going to add a fixture. Okay, so that's coming down here. I'm going to rename this. Now I have two parts of this fixture. I have my first part, which is going to be a DX6. Now I downloaded this from their site, and then from there you can just bring it in and import it. But there's going to be a little bit of a trick right here, and I want to cover it right before we get started because I don't want you to get too far down the line and then get kind of frustrated. I'm going to come down here and I'm going to go to add model, and I'm going to go to model file, and I'm going to come up to again where I have all this located at, and I'll have this attached in the description below as well. So here's my model that I downloaded. I have a fixed and movable. Now I separated these a little bit so it'll look a little bit better. So I want to bring in this first. I'm not going to bring in the STLs. I like to bring in the .plys. Seems to work a little bit better. Now when it first comes in, notice my orientation when I first turned on my Vericut project, it's already in a certain orientation. Now when you save your models, when it was saved by the designer, it was saved at a different orientation. It just doesn't matter, okay? So what I want to focus on first is getting this to the same orientation as what my machine is located in, because I want my spindle to come down on top of my part. I don't want it trying to come up through the bottom of the part. So do not try to manually rotate this with your mouse. We're going to actually go into Kirk Vise. We're going to rotate it. I'm going to change this to 90. And then I'm going to just try to get it to the right way. So that looked good, and that looked good. So you'll notice the orientation looks just like this right here. Okay, so if I was looking straight down on top of it, that's what I would want right there. So I'm going to click off of it, and I'm going to go ahead and minimize. That was probably half the battle right there with our fixturing. So now we're going to come up and we're going to make our stock, but before we do that, let's come up here and see what we're going to be making. So my material is going to be 8 3/4 by 2 3/4 by 1 inch thick. We're also going to vise onto a 1/4 inch max with our hard jaws, and we need the material to be hanging out of the left side of the vise 1 3/300. So we're going to go ahead and do that right now. So I'm going to click on stock. I'm going to go to component. I'm going to come down here to model, and I'm going to click on block. Now when this comes up, it's just going to put some material right there in the middle. I'm going to go 8 3/4, and I can hit tab or I can click on the next line, whichever one you prefer. I'm going to hit 2 3/4, tab, and then it's already set to 1 inch, and I can hit enter or whatever I need to do. So now that is actually right where we need it to be orientation wise, so we don't need to rotate our material. The next thing we're going to do is we're going to use the assemble function to kind of mate it against the right surfaces, but we need to kind of move it close. I find it's a little bit more helpful to do that. So in translate, I'm going to go 5 inches. I want to go up 5 inches. So I'm going to hit move, but if you'll notice, it went the wrong way. So if it does this to you, you can simply hit back, and then we're actually going to move it minus. So the way Vericut is incorporating this, it's thinking that's moving in a plus value. It gets kind of backwards. You can't always get it right the first time, but that's okay. That's why that move back or reset is right there. So now we're going to go into the assemble function of this, and we're going to keep this in the mate. We have different constraint types. We'll use a line here in a little bit, but we're going to go with the first one, and we're going to simply work on getting the bottom mated to the top, and then we're going to lower it a minus 250 thousandths. And I want to hit enter. I want to watch it. You can see it did go the right direction. So that worked out pretty good. So next we'll go ahead and hang it out. 1 inch 300 thousandths. But when I mated it, it kind of flipped it. It's kind of annoying, but it's not a big deal. So to fix it, I know my material was 8 inches 750 thousandths. And if I'd hit enter when I zoomed, it moved it, but it went the wrong way. So I'm actually going to put it in a minus and hit enter. And you'll notice that it did go the correct direction, but it's flush. So I'm going to let this software do the math for me. So I'm going to type in plus 1.3 and hit enter. So it was actually a shift of 7 inches 450 thousandths in the negative. So that looks pretty good. The last thing I got to do is I got to get it flush with my jaws. So I'll come here to the last one, click on that surface, click on the face, and everything looks really good. So right here, I have my part positioned in the correct location. I am now ready to add my moving jaw so that we can get it to clamp on my material. So I'm going to come down to here. I'm going to right click on the Kirk vise. I'm going to go to append, and I'm going to put another fixture that carries the same alignment as this one, so that way there's no aligning once you get it in there. So I'm going to rename this as movable jaw, hit enter. I'll come down here to the model, and I'm going to go from model file, and then I'll do the same thing. I'll come back to my Vericut. I'll go to my Kirk vise, and this time I'm going to get my movable models. I'm going to do the same thing. I'm going to grab these PLYs right here, and I'm simply going to hit OK. So you'll notice it kind of brought an extra screw in there, which is kind of odd. It's all right though. It's not a big deal. And I'm going to go ahead and click on that one screw because I don't need it, and I can just delete it right there. So now let's go ahead and get this movable jaw flush with my material. I will click on moving jaw. I will go to assemble. I could go to align, but we've done mate so far, so let's go ahead and do that. I'll click on the arrow. I will click on that surface. I will click on that surface, and if I click out anywhere out here in space, it just takes it off from being highlighted. So this is really cool. So I have everything. If you wanted to, you could build in some parallels right here. Just kind of give you a more realistic idea, but this is just keeping it pretty basic. The next thing that I think everyone's going to like, this pretty cool little customization, is maybe I don't like the color of the vise right here. Maybe I want to look a little more realistic. So what I'll do is I'll come down here to component, and I can go to appearances, and let's change it to something a little bit more realistic on the steel scale of it. And then I'll hit OK, and let's say this moving jaw, let's make it match. So we'll go to the same thing, hit OK. If I wanted to, I could grab that bolt, and like I said, I want to change just that one color of that bolt. I could also go to model, it has an inherited color, so I'm going to click that off and we'll just make it a darker color. See it right there. And then if you know what vices look like, this bottom area is going to be blue. So I just kind of exited my box right there and I clicked on that. Same thing, click off inherit, and then I'll go to blue right here, and then I click off of there. So it's really cool. You can customize this. You can change every single component of this vise to a different color if you'd like. It's just whatever you feel comfortable with doing. So now let's go ahead and get rid of our vices right here. Let's just minimize our drop down menu. Now it's going to be very similar to how we did our last video. I'm going to click on my material. I'm going to go to the appearance of it, and I'm going to make it a little bit translucent, so 0.5, and hit enter, because when I bring in my model I want to see everything. So I'll exit that. So now is when I'm going to go to my model and my design. Now when you click on design, it's going to come up as invisible. So you want to make sure it's visible in both views. We're going to go into adding a model file. And I'll go ahead and again, this is where my model file is at. So I had a stock, so you could bring in a stock and then position it, but the block worked out just as well. So here's my model. I got it as a .xlt. You can do a SolidWorks part. Sometimes the SolidWorks, if you have it and the license with Vericut, don't seem to make that handshake. So I'm going to go ahead and use a .txt or a Parasolid. I'm going to hit OK, and it's going to bring it in pretty much in the same location it brought the material in. And I'm going to follow the kind of the same pattern I did before. I'm going to go ahead and translate it up. And then I'm going to go to Assemble. And here's where I'm going to go over the aligning. So I'm going to change all these to align. There's not a lot difference with the mates, but I'm going to go ahead and change them to align. Now I want to look at my information here. Now it says XY0 is 75 from the top left corner, and the in X and minus 75. Now here's what's kind of tricky. You have to take your time on this. Now if you look right here, when I went into my CAM software, my XY0 for my coordinate system is the top left corner. Now I moved my model in from that corner 87 thousandths and 50 thousandths right here. So that is what I'm going to be moving my material from that corner. So we're going to align it with that corner, and then we're going to move it over and over. Now it is flush with the top, so I'm actually going to have to move it down into the part for that. Now that's going to take a little bit to sink in. It really depends on how you make it in your CAM software, but let's go ahead and do that right now. So that 75 thousandths that we were looking at, that's not going to have anything to do with how we're modeling it right now. So let's go ahead and do our first aligning. We'll go ahead and grab this and move it to there. And then again, it was 87 thousandths. So 0.087. If I hit enter, hey, it went the wrong way. So I'm going to go ahead and put that as a minus and hit enter. And you see that it does go the correct direction. And now I'll go ahead and I'll click for my other side, which will be this side of the part to this side of the stock, and then we'll put a minus 50 thousandths in here, see if it goes the right direction. It did. Kind of hard to see. If you need to, you can rotate it to see that it is going into the material. And then the last one, we'll click the top of our part, top of our stock. Now I'm not going to move this down 50 thousandths because whenever I made my CAM software, I kept this flush with the top of the stock. So now we have aligned, we went through the aligning constraint type for positioning our part so that it, if I look at it, if I go top, you can hold the middle mouse and you can zoom on stuff. So if I bring in this image, you can see that it does look very similar to that. And that's what we want. So from here, I'm going to go ahead and add my coordinate system. I'm going to zoom out a little bit so it's easier to see. Click on my home button. I'm going to get rid of all that ladder so it makes it a little bit cleaner over here. Now remember, in my image right here, my thesis is the corner, so that's what I'm going to do. I'm going to keep that in the corner. So I'm going to add a new thesis, and it's pretty easy. I'm going to click a vertex, And I'll come up here and I'll click up this corner. I'll zoom up a little bit. Now remember, in my CAM software, I moved the model into the part, but I kept the face of the part flush with the stock. So in here, I will need to lower this 50 thousandths. Now see, it did go the opposite way, so I'm going to move it back. I'll take out that minus and I'll move it down. That way Z0 will cut at the top of this face. And then I'll simply just click off of it. But now my program uses a work offset of G54. So we're going to call this 54. And then I'm going to go off the CSIS location number 1. And then I'm simply going to click add. So now I have a coordinates for right there. So that was really easy. Now the next part is we're going to add the tooling. Now I'm going to spend a little bit of time on here because this is where you're going to have a lot of questions. So I'm going to double click. I'm going to bring up my tool library now. In my last video, we went through and built every single tool. I don't want to do that because if you'll see here, I've got a face mill, I've got several end mills, I got ball noses, and a chamfer tool. Now what's interesting is these 4 tools, one's a 1/2 inch, one's a 3/8, this is a 1/4 inch, and that's a 1/4 inch. But in my tool inventory, all of these tools have 3/8 shanks. Very interesting, but that's how I have it. So I can actually use the same tool holder for all 4 of these. So I'll actually only be grabbing a face mill, 4 of these style holders, and 1 1/4 inch holder. So that's going to make it a lot easier, especially because we have access to a master. So let's go ahead and minimize that. And right here, I'm simply going to right click. I'm going to search for tool. I'm going to go into this looking for browse. And then I have mill tools, which I'll include in the description below. And I'm simply going to click on it. So now it comes up with this master tool list that I've already made. And I'll kind of move this over so you can kind of see. Now this is the brand. This is a Cat 40. I have some Cat 30s in there for different style machines. I have a mild description of what's in these holders. Now you can build your holder library without adding a tool. I just happen to add the tool in there so you can kind of get an idea. You know, this is a Cat 40 holder. It's got a 2.5 inch gauge length and it can hold a 3/8 shank. So in the picture here you can see it has a 1/2 inch tool with a 3/8 shank. So I'm actually going to need 4 of these. I'm also going to need a face mill, which has been designed already down here, and we can go in there and change this diameter if we need to. And I'm also going to need this 1/4 inch, which by default had a 90-degree chamfer tool. I got kind of lucky there. So let's do this in order. I want that face mill. I'm going to simply click duplicate. And if you'll notice up here, it brought that tool into my new library. So let's come up here to this tool right here. And like I said, these are the same things. One's a 2.5 inch, one's a 3 inch. So maybe I want that extra clearance right there. So I'm going to grab 4 of these. So I'm going to go 1, 2, 3, and 4. We'll grab our 1/4 inch and we'll duplicate that as well. We are now done with this right here. So I'm simply going to close it. And there's a lot going on right here. So the first thing I'm going to do is I'm going to kind of minimize this so we can take our time right here. I'm going to spend a little bit of time on this. If you're already familiar with how to do this process, you can skip ahead. But I want to make sure for those that do not understand how to do this part that I cover some of the basics when it comes to doing this. So let's start off with our face mill. And the first thing I want to do is I want to rename all these tools. Now, sometimes with the renaming, I'm just right-clicking renaming, and I'm just hitting enter after I rename it. And I'll show you why, because it can get real frustrating whenever you're doing it and you have multiple tools with the same name. So this really helps me kind of navigate this a little bit better. So let's start with the first tool. It is a 3/8 or 3 inch face mill. So if I come up to here, it's tool number 1. So I'm going to right click, I'm going to hit 1 enter. Also very important, as soon as I do that, this has to be a 1 as well. Think of this as your H and that is your T. So your T and your H have to match or your simulation will not work. So if I drop down to the holder, you'll see that I've created a DXF. So I made some geometry. I imported it using the import DXF function, and then it wraps around. So everything right here is an actual holder. And this would be the inserts. Now there are ways of building inserts. I actually went the simpler route. I went to the cutter. I just made a really fat end mill. So that is 3-inch end mill right there. And you kind of get the idea. You can put a radius on there, but it is a flat 90-degree surface right there. Works out just fine for what I'm doing because I'm facing. So that tool's done. And if you wanted to, you could change your descriptions to whatever you wanted to. And when you're done, always hit enter and it will save it over here. So tool number 2, if I come up to here, is going to actually be tool 3, a 1/2-inch end mill with 800 thousandths length of cut. So I will simply come up to here. I will right click and rename to tool number 3. I'll hit enter. I'll come down to here, hit 3, hit enter. If you don't hit enter, it won't always save it. Let's come to that cutter. You can see it's a 1/2 inch. It's got the 3/8 shank, and it's already at 850 thousandths. But let's change that. Let's take off that 50 thousandths and hit enter. Let's look over here. See, it just made it a little bit shorter. That's all it is right there, is change that right there. So let's go ahead and close that one, and let's just keep going. So I got the next one. It is tool number 4. It's going to be a 3/8 with a 1-inch length of cut. So let's come here. We'll rename it to tool 4. We'll change the value down here to 4. And then we'll go right to the tool, which is going to be a 0.375. And it says it had a 1-inch length of cut. And I click off of it, and you can see that there's just a little bit of flutes hanging out. And if you install your tool and it's sticking out longer, I can simply come up here and make that 1.25, and you can see that the tool is hanging out just a little bit more. It's up to you on how you want to do this part. So that tool's done. The next tool is going to be a 1/2 inch. The next 2 tools will be 1/2 inches, but one is a ball nose and one is a simple end mill. Now, my end mill is going to have to be longer than a 1/2 inch. That was just kind of a generic post in there, or else it will cut the tops of my part. So I'm going to change this to just 800 as well. And we don't have to save anything, just to give you guys a visualization. I'll come back up to here to my next tool, right click it, rename, tool number 5. Come to here, make that a 5 as well. And then we'll go to the tool. And then we're going to make it 0.250. And then we'll make that 800. Because a lot of times the end mills that I have a little bit of a taper here, and it doesn't always show that. And some of them are a lot longer. Some of them are, 750. Some of them are 1 inch. I mean, it's just whatever you want to show in there. So that works out pretty good. We're not too worried about that. And so the next one, we're going to go over here. It's going to be tool number 7. It's going to be my ball nose. So we'll right click, rename. We'll go 7, enter. 7, enter. Go to the tool. We're going to go to ball nose right here, and we're going to make it 0.250. And we'll go ahead and leave it like that. I mean, if I wanted to, I could change this to 375, and I can change, maybe it doesn't have that much length. Maybe it has, 1-inch length of cut, just like the other ones. We can make it look however you want to make it look, but it's always good to go out there, find the correct holder, install your tool into it, and set it up. And then the last one is going to be, I believe, tool number 8, and it is a 1/4 inch shank 90-degree chamfer tool that comes to a point. So over here, we'll right click it, make it number 8. We're almost done. This is actually not taking as long as I thought. We'll come up to our cutter. Now you'll see, I'm going to zoom up on it, that it is already got a 0 radius at the corners. It already is what they would call a conical end mill. I'm going to call it a chamfer tool, but you'll see I got 1/4 inch here sticking up in there, and I click off of it. That's just fine. It's just doing a chamfer on my part. And so there we have it. We're all done. And so when I hit exit, it'll say, oh, do you want to save? And I do want to save it. So I'm just going to go ahead and save it. We'll save it in here, not as my milling inspection tools, but I'm going to save it as my demo tools. So you can always save it right there, or you can save it as your new master if you don't have one. So I'm going to go ahead and hit exit right here. I don't want to save it. Like I said, I was just doing that for visual. And next thing you know, I am pretty much done. The last thing I have to do is I'm going to go to NC Programs. I'm going to add the NC program, which that's the one I just didn't edit. I didn't save it. I can double click it and you can see everything that we've been looking at is right there. And here comes the fun part. We've built our material. We built our stock. We imported our fixturing. We got our orientations right. Ooh, here comes the nervous part. Let's hit play. So you'll notice it comes in. It did face my material. It is going through the part. And we'll go ahead and speed this up a little bit. We can see that it's going through and do the pocketing. Everything looks pretty good. Like I said, it's a verification software, so we want to go ahead and run everything. We can see where the ball nose runs, the profile, the chamfer. That all looks pretty good. Now the last thing, this is where it's the cringe moment. I'm going to go to Analysis, and I'm going to hit Compare, and I should see nothing but clear. You'll see I got a little bit of graphics going on the face right here where the chamfer runs. Not a big deal. It did run it. We did see it cut. So right here, this looks amazing. So whenever I set up everything, this is what I'm looking for when I go to send it out to my machine. Now keep in mind, I'm still going to set it up with these instructions for the operator. Now the operator does this. There's plenty of this material around the stock for it to make a good part. But for putting this into Vericut and going over and making sure everything looks right, that's pretty much all we got. So we successfully brought in our control and our machine file. We created our Kurt vise by installing a hard jaw and our movable jaw. We went through and made our stock, our model, our design model, and then we went through and created our coordinate system, our work offset. We were able to bring in all of our tools from our master. We loaded our program and we simply hit play. All right, well, that pretty much sums it up. This was a pretty lengthy video. Down in the description below, I'll go ahead and add some timestamps in there so we can kind of skip through to those fixturing moments and maybe that master tool list process of building all that. But for the most part, you all should be getting the hang of this for the milling side of things. We'll start working on lathes and maybe introduce some 5-axis rotation maybe later on. I don't know. But again, I really appreciate you all tuning in and watching these videos with me and kind of going over these things. I kind of make these videos so that me personally, I won't forget these in the long run. So being able to share that knowledge with you is something I have the pleasure of doing. So, but beyond that, thanks again for watching. My name's Aaron Runt. Have a good day.